Okay, here we go. Let's get through this quickly, so you can go work in the lab a little bit, get questions answered. All right. Airplane flies with an airspeed of 157 kilometers per hour. Wind blows at 77.9 kilometers per hour at 39.7 degrees east of south relative to the ground. Okay? So we want to know two things. In order to land the plane at an airport due north, how do you steer it? And B, how fast does the plane actually end up going along that course? What's its speed relative to the ground? Okay, so we need a picture, don't we?
Let's do the wind.
So, yeah, right, so we got our picture here.
Give me the fourth chord. Oh, yeah.
The wind, so if it's 39.7 degrees east of south, we're starting where and swinging in which direction?
South to the east.
Good. So starting south, swinging east, right?
Yep.
Okay. So the airspeed vector is going to look like, the wind vector is going to look something maybe like that. Where this is a 39.7 degree angle. Well, you can't read that, can you?
So you always start with the second number.
Yes. Second one.
Okay. And the magnitude is 77.9. Okay? So we need to figure out the components, don't we?
Yeah.
Of the wind. So the wind is going to have, it looks like a southerly component, which is, if we think of it in terms of north, that would make it sign negative. Good. And then we're going to have, it looks like an easterly component, right?
Yes.
Okay. So what do you think that means for the plane? What are we going to have to do to the plane then? How are we going to have to compensate? It's going to have to steer a little bit west, isn't it?
Yeah.
Right? Because as it's flying along, as it's flying in this direction, this wind is going to tend to slow it down and push it off course to the east a little bit, right?
Mm-hmm.
Okay? So it's definitely, the plane's going to have to do something like this. It's going to have to push up there at some angle theta, which we're trying to find.
Yes.
The magnitude of the plane's, its airspeed is 157. Okay?
Yep.
Right. So, what do you think?
Gotta find the X.
Okay, we got to find the components of the wind, don't we?
Yeah.
Okay. So W sub x is going to be what? So that we'll call this W sub x.
It's gonna be opposite.
So what do we think about that? Andy, you tell us. What do you think? What's your thinking about that? What's the x component of wind going to be? What do you think? Okay, stop writing for a second. So you know that you're always going to multiply. If I want to find a component, I'm always going to multiply the overall magnitude by either side or cosine, right? Here's the angle right here, right? Here's the angle. This is the component we're talking about. So is it the opposite or the adjacent?
Opposite.
It's opposite. So what's that tell us? Sine, good, because of so ka. Right? Does that make sense?
Yeah.
Okay. So it's going to be, in this case, it's 77.9 sine of 39.7 degrees, right?
Right.
Yeah.
Some number, right? W sub y,
It's just cosine.
okay, positive or negative?
Negative.
Negative, good. So if this is W sub y, we might as well get that out of the way too. W sub y is negative 77.9 cosine 39.7 degrees. Okay, good. All right, so what is, we don't know what theta is yet, right? But what, in terms of theta, which we're trying to find, what is going to be the x component of the plane's motion?
The X of the wind.
Right. Well, okay, it's gonna have to equal the x component of the wind, but if I were to draw this as components here, this is, call it p sub y, and that's p sub x. What is p sub x in terms of theta?
Opposite. Oh, wait,
What do you think?
mean that?
Frank, what do you think? Here's our right triangle. The hypotenuse is 157, right? That's the magnitude of the plane's speed. What's that gonna equal? 157 perfect sine theta, right? Very good, okay? We know that we want the plane to go due north, and so we want the plane's horizontal velocity to exactly counteract the wind's horizontal velocity, agreed? Okay, right? So then aren't we setting these two essentially equal to each other?
Oh, yeah.
Right? They have to add, see what I'm saying? They have to add to zero. Another way of saying that is, we know that P sub x plus W sub x has to equal to 0, right? Okay. So then, doesn't that mean that P sub x just equals negative W sub x? Right?
That's
Agreed?
different than the other one we've done.
It is.
Yeah. We did it
The
different
other
ways.
one was like the exact same as X.
Well,
This one's now.
Okay, so, I mean, there's a couple ways we can think about that. If we, there's, you know, we can do it in terms of this equation, but you could also if you wanted to. I mean, as long as you pay attention to the direction of this vector, and it's clearly negative, isn't it, right? We could say, well, the length of this part of this triangle, right, this component which forms the horizontal leg of this triangle has to be the same as the horizontal leg of this triangle.
They're just going.
And so you don't even, that negative sign honestly is not that big a deal. We could just say, okay, well, we know that has to equal that, but we know that this is going to be a negative component because it's pointing in that
Okay, I see,
direction,
I see. Yes.
right? Would you prefer it, maybe that's the way we talked about it, and that's fine. So let's set that up then. So 157 sine theta equals 77.9 sine 39.7 degrees. Now, this is just a big number, isn't it, on our calculator, right?
Yes.
I'm writing it like that, but we could just as easily make it a decimal. What do I have to do to solve for theta there?
Divide by 157 and then do our sine.
Okay, good, and this is a little bit of trick, right? This is the part that's a little bit tricky. If we want to get to that sine theta, first we have to isolate the sine theta. The first thing we want to do is we want to undo multiplying by 157, right? So we're going to divide both sides of this equation by 157. So those cancel.
Yeah.
What are we left with then? Well, we're left with sine theta equals this number. This is a big number. 77.9 sine 39.7 degrees. That number divided by 157. It's still just one big calculator number. It might look scary, but it's just a number. What's the last step? How do we get the sine by itself? Yeah, arc sine or inverse sine of both sides, right? So then we end up with our final answer just being theta equals the inverse sine of all that stuff. That's
Will
it.
that make us find the degree? So that's for the.
That's gonna find the degrees,
Okay.
right? So let's do that. Let's find the degrees.
Are you recording this?
I am. Yep.
Okay.
What mode does our calculator have to be in?
Degrees.
Degrees mode. Good.
Okay.
And is everybody's clear with this, why we did the inverse sine thing?
Yeah.
Right? That's how you undo a sine. Okay. All right, so then we're just gonna go inverse sine, so second sine of all this stuff. Let's be fancy and use a fraction template, just so we can keep it organized. So the inverse sine of 77.9 sine 39.7 divided by
157.
157. Okay. Close the brackets. Hit go, and it tells us 18 point. So how many sig figs we keeping?
3.
Wait,
Three, I think it was, wasn't it?
Wait.
18. No, that's right. We'll see, I think, because look at the angle. So let's write that down. So we get theta, and I'll get rid of this calculator. Theta is roughly equal to 18.5 degrees. Go away, please. Okay. That's reasonable, isn't it?
Oh,
Right.
I thought it was like the whole
No, that's right. So all we did is we just did it for this triangle, right?
thing. Okay.
Everybody agree? We figured out that p sub x has to be, 157 sine theta is what that is in terms of this triangle, has to equal the x component of the wind.
But you did.
And when all the dust settled, when we set up that equation and
Yeah.
solved for,
Could you also just get the number of that one x, make it negative, and then do the cosine? No, never mind. I know it's too. Never mind.
right.
Never mind.
Yeah, okay. So now we know what we're gonna head, how far north of east though, right?
Yeah.
The angle that we found, is that north of east?
No.
No, that's only the little piece at the end of that that's gonna be west of north, right? To get north of east, we have to start east and swing all the way up to there. So what do we have to add to that then?
90.
90, right. So our answer is gonna be then, what was that for our, I forgot what that was, 18.5, so what?
108.5.
Yeah, 108.5, 90 plus that. 108.5, which to three places is 109.
Yeah.
Okay.
And then
I
what's
think-
next, the plane speed.
Okay, what was the calculator? I gotta check something on the calculator. It was okay, but is it really though? Because look, if we add 90 to that plus 90, see we pre-rounded. See the danger?
Oh.
Now what's it gonna be?
108.
See what I'm saying?
Uh-huh.
There's a great illustration of the danger of accumulating rounding here. You only round once, right? Because if we added 90 directly to this without rounding, we get 108.47, which rounds to 108. Aha,
I
okay.
think it's significant.
That's like.
So 10. Okay. Now what about the plane speed
Relative to the ground.
relative to the ground? So how are we going to find the plane speed, given that we now know what theta is, right?
We add up the y.
Okay, we've got the y component of the wind.
We need
Right.
the y of the airplane.
We need the y of the airplane. How are we going to find that based on this picture?
We go
Use the X.
You can do, wait, let me think, adjacent cosine. Second, no, yeah.
Okay, let me go to I'm going to get another page here. So if we were to focus in on the plane's motion again, right? The plane is actually pointed in that direction, and it's got components of, if that's theta, and this was 157, we said this was 157 sine theta. What's the y component? 157 cosine theta. Well, we know what theta is. Theta is in our calculator,
Yeah,
right?
it is.
Theta is right there. It's the 18 degrees for our little triangle, isn't it? Right? So the y component then is 157 cosine of that, right? There's the planes component. If we made a little table out of this, right, for the airplane, we've got vector p, let's say, vector w, and we've got the x component and the y component. Well, I already know that the x components added up so that the resultant was 0, right? We already did that. All we're looking for, everybody agree?
Yeah.
Okay. I mean, we could put those numbers in there, but they add to 0. The y components though, the plane's y component is that. So it's roughly 148.905, blah, blah, blah. It's in our calculator, right? What about the winds?
Plus.
Well, the winds is
No sign.
right there, isn't it?
Negative.
We already found it.
Yeah.
The winds component, we said, remember down here, we said it was pointing down and it had magnitude 77.9, cosine 39.7, but it's down, so it's negative.
Yeah.
So all we have to do is put that in our calculator, which gives us what? Negative 77.9 cosine 39.7 is that. So it's in our calculator, right?
And we add those suckers up.
Right. So now we'll just go back to this page. We've got negative 59.9, blah, blah, blah. Add those up in our calculator and get what? Well, that
90 something.
plus that is that. So 90.0?
No, it can be 3. Oh, yeah, it would be, yes.
Yeah, but it still would be, right?
Yeah.
Because if the next one rounds up, okay? So our components are 0 in the x direction and positive 89.0 in the y direction, right? So what's the plane's airspeed?
89.
89. It's all north. It's got no, right? It's got no
It's not like
east
this.
component at all. It's all north. 89.0. So let's enter that and just check ourselves. Well, do you remember what the first one was?
108.
108. Oops. 108.
That's pretty cool.
108, comma. Oh, nothing's happening. What's going on? Well, 108, comma, and then what was the last one? 89.
89.
Because it was 88.
Got it.
Yeah, so,
Okay. Make sense? That one's, like I say, remember I told you that one's going to be worth, you can still get an A on the test and not get that one right, but you just can't get a high A on the test. It would be a lower A. Yeah, how rude of me, exactly. Okay, let's go back to 209.